Because of the length of the video, I've decided to break this up into multiple parts. So let's begin with part 2. If you haven't watched part 1, I will put a link in the description below. In part 1, we took a look at the signal tracer, its condition, the paint deteriorating, and the rust. We then moved on to describing what the front panel controls were. We looked on the inside and discussed the tube layout and the bottom side. We then did checks on all the transformers and found that the power switch was bad. We opened up the power switch and found that there were components that were missing inside, reinstalled it, and now we're ready to test. Okay, what I've done is I've hooked the unit up to my new dim bulb tester that goes through my isolation transformer and variac. I'm going to slowly bring this thing up in voltage. We'll be watching the voltage here. I'm coming off of B+, and I should be reading somewhere around 310 volts. So let's start bringing it up. There's 20 volts. There's 40 volts. We're going to leave it at 40 volts here for just a few minutes. I'm not really certain about some of these caps. They look cracked. And this big filter cap is probably definitely bad. Well, I'm starting to see a little bit of a rise here at 40 volts. We'll let it continue to rise until it levels off, and then we'll turn it up, turn the AC up some more. At this time, I'm trying to smell to see if I smell anything burning. If I can smell the odor of excessive heat. A couple of the caps, just checking to see if I can feel any heat coming off of them. Okay, we're at 26 volts there. Let's bring it up now to 60. And I'm starting to hear a hum in the speaker. That is a very good sign. Okay, let's turn it up to 80. We're going to turn it up to 90. To 100. To 110. To 120. Okay, it's still climbing, but relatively slow now. I think what we'll do is we'll let it sit here and run. We'll see if anything else happens. But I think what we're seeing now at 293 instead of 310 is that the filter cap is probably bad, which I know it is. And once we replace it, that voltage should be right on the money. So I'll be back in a few minutes. Okay, I've let it run for about 20 minutes and I'm almost at 300 volts. We're going to call that good. I want to turn it off momentarily, remove the test leads, and show you the magic eye. Okay, power is back on again. And you can see that we have a really good magic eye there. If I were to touch the input, I hope you can see the magic eye there. So the magic eye is working. So the next step now is to make up a parts list. Go to the garage and look through my parts bins, see what parts I have, what I don't have, and get things on order. When I have what I have, I'll be back and we'll start checking resistors, replacing them, and replacing capacitors. Okay, the first thing I want to do is replace the electrolytics, and while I'm doing that, check out the resistors and any soldering mistakes. This filter cap right here, there are a couple things that I can do with that. On the bottom side, it's right here. There are 4 lugs and 2 twist terminals that are ground. There appears to be enough room in here that I could put the electrolytics, even mount them over here. The can is 4 20 microfarads at 450 volt. The other thing I could do is I could replace the can with a manufactured look-alike can, or I could go ahead and try to restuff the can. The easiest of all these is to mount the electrolytics someplace over here or over here, and then use some sort of solder terminals to attach all the lugs to. The ordering of the look-alike cap would cost a tremendous amount of money to do. I haven't looked it up, but I would guess between $50 and $100 to have that can replaced. The option of restuffing this capacitor, you're looking at an extra amount of work to remove the components, pull the capacitor out, heat it up with a heat gun to melt the internal tar that's in here, pull the guts out, clean out the tar, and then put capacitors internally in, run the leads back out this protective cover, and then to the components. Which is the best option? Well, if it were an antique piece of equipment that I was trying to retain the original looks, I would go with the restuffing. If I was just trying to get this up and going, I would go ahead and mount the caps someplace inside of here. If this were a customer's and he was willing to pay to have a $100 can put in, then I would go that route. Well, on this project, I decided to go ahead and show you how to restuff a can. The problem that I'm going to have is that there are 4 caps in here, and these lugs are really filled with components. Trying to keep them straight so that I don't misplace any one of the components is going to be a challenge, but I think it'll be worth it. So let's get started. After removing the can, I decided to make a separate video on recapping electrolytic cans. I'll link the video in the description below. Here are a few pictures from that video. I peeled back the aluminum holding the guts to the electrolytic can, then heated the can with a hot air gun until the tar melted. I pulled out the interior, cut it off, then reinserted the new electrolytics, put it back into the can, and then refolded the aluminum back over. The last step was to mark the can, indicating that I had put new capacitors inside of it. Well, now that we have the can restuffed, it's time to go ahead and mount it back onto the unit. When we remove this, we started with this lug and went counterclockwise to the ground. So now let's go backwards and hook these wires back up. I do have a 33K resistor here that I need to hook back up, which is right here. In place of, I believe, this resistor. I think this is the one that measured off. But we'll check it before we put it in. Yeah, this 33 is measuring 38, so we're going to replace it with a 32.8, 32.9. Just wanted to tack that in till I get these other components on here. Okay, now that we have the cap in, I've got the unit plugged into the isolation transformer Variac. And we're going to slowly bring this up again. And we're going to look to see if we've got the 300 plus volts off of the 6X5 rectifier. So it's turned on. And let's start bringing it up here. Okay, we're going to start bringing the voltage up here. The unit is on. We're at 20 volts. We're at 40. We're at 60 volts. We should see the heater filament starting to warm up. We should see some voltage starting to happen here on the meter. There we go. It says here this should be, looks like 300 and some volts. There's 80. There's 100. There's 120. But now I have no tubes in here. So let's bring this back down again and let's put tubes in and see what that voltage reads. Okay, we're going to slowly bring that up again. We're going to bring it up to 60. And there we have tubes warming up. Okay, we're at 80. We're at 100. We're at 120 volts. And I'm reading 315 volts there. Okay, what I'm going to do is turn it all the way down. Whoa. And we're going to short out the input. There we go. I think that is the ringing of the tubes that we're hearing there. But it sounds pretty quiet with these old capacitors still left in here. And we're reading 311 volts. $315. This side should be 260, 275, and this side should be 200. $221. Okay, let's turn it off. In our next part, we'll continue replacing capacitors and resistors and troubleshoot the crackly RF gain control. If you found this video useful or entertaining, give me a thumbs up and don't forget to click on the bell icon to be notified of upcoming videos. Stay safe, stay healthy, and thanks for watching.